Alright, and here is the final video. I'm going to make this one short and sweet as best I can. So number 32, really the first thing we have to do here, guys, is square both sides. We don't need to move anything away from either side of the equation. We are free to simply square both the square root of 2x minus 11 and the x minus 7. So I'm going to do that. Square that. Square that. That will get rid of the radical symbol, and we'll be left with, on the left, 2x minus 11 is equal to x squared, or x minus 7 squared is just going to turn into a trinomial, right? Where we have x squared minus 14x plus 49. If you can't do that in your head, don't worry about it. Write it off to the side somewhere, but we will get x squared minus 14x plus 49. Right, now we need to combine like terms and get 0 on one side of the equation. So I'm going to subtract 2x and add 11 to both sides. So we end up with x squared minus 16x plus 60 equals 0. And that's kind of nice because immediately I can see that the factors, well, they both have to be negative because we have a positive product and a negative sum. So really I can see right away that we have x minus 10 and x minus 6 as our factors. And when we set those equal to 0, we get the solutions x equals positive 10 and x equals positive 6. But we need to check, guys, so I encourage you to check either on this page or on a separate piece of paper. Maybe you thought further ahead than I did and you're actually doing this work on a piece of line paper, not actually on this page. But if you are, check somewhere, okay, and try to leave space. So here's the check. We're first going to check x equals 10. And that's going to look like, going back to the original equation, does 2 times 10 minus 11, there go the lights again, does 2 times 10 minus 11 equal 10 minus 7? We're going to put a little question mark over the equal sign. Is that a true statement? That's what we're checking, right? Does the square root of 2x minus 11 equal x minus 7 when x is 10? So here we get 20 minus 11, which is the square root of 9. Does that equal 3? And we know that the answer actually is yes. That's true. So we know that x equals 10 is good. Is x equals 6 also good? Let's see. If we check x equals 6, we get the square root of 2 times 6 minus 11 equals, with a question mark, 6 minus 7. Well, we know 2 times 6 is 12, and the square root of 12 minus 11 is the same as the square root of 1. And is that equal to negative 1? That's a big question mark, right? Because the square root of 1 is actually just positive 1, but positive 1 is certainly not equal to negative 1. So really, x equals 6 is extraneous. Okay, x equals 6 is extraneous, so really the only solution that works is x equals 10. So be careful for those extraneous solutions. That's, in fact, it says that right over here, right? Remember to check for extraneous solutions. So if it says that, there is likely going to be at least one extraneous solution in the problem or problems that you're working out. Okay. So we're going to look at numbers 38 and 40 from this next section. And I'm going to give you a warning here, guys. 38 took me quite a while because there are a lot of little steps. So as much as I kind of said I was going to try and make this short and sweet, there's kind of a lot to it. So here we go. First thing we need to do here, guys, is we need to get rid of the 9 from the left-hand side of this equation so that we have just an x term on the left equals a constant term on the right. So I'm going to subtract 9 from both sides. But how do we subtract 9 from 69 over 8? Well, 9 is actually 72/8, isn't it? If we were to try and turn 9 into a whole number in order to into a fraction, excuse me. If we were to try and turn 9 from a whole number into a fraction with a denominator of 8, really it would turn into 72 over 8, right? So what we're left with then is negative 3 times x to the negative 3/4 on the left, that's going to go away, is equal to 69/8. I'm going to get rid of that too. Minus 72/8. Remember, that's just 69/8 minus 9. 69 minus 72 is negative 3. So really, we get negative 3/8. Okay. And what do we do next? Well, now I need to get rid of this negative 3 that's blocking the x. So we're going to divide both sides by negative 3. But that's weird. What's negative 3/8 divided by negative 3? Well, you can think about this like dividing by a fraction, right? Dividing negative 3/8 by negative 3 over 1 is the same as multiplying negative 3/8 by the reciprocal of that, which is 1 over negative 3. And when we do that, we can see that the negative 3's are actually going to cancel each other out, and that negative goes away too, right? And we're left with just 1 over 8. So there's a lot going on there, guys. Perhaps consider rewatching, back it up a little bit if you need to. What's going to happen here is we're left with x to the negative 3/4 equals 1 over 8. Okay, x to the negative 3/4 equals 1 over 8. Now, in order to deal with that fraction in the exponent, I need to raise both sides of this exponential equation to the power of whatever the reciprocal of that is, because really I want to get x. I don't care about x to the negative 3/4, I just want x by itself. So I need to raise that expression to the power of negative 4/3. Okay, because if I do that, then multiplying negative 3/4 by negative 4/3 gets me an exponent of 1, which will allow me to solve for just x. So I need to also do that to the other side, right? If I'm raising x to the negative 3/4 to the power of negative 4/3, I also need to raise 1/8 to the power of negative 4/3. It's got a little messy. Sorry about that. We're going to take 1/8, raise it up to the power of negative 4/3, and what we're left with on the left is just x, which is great. On the right, we have, I'm just going to distribute that exponent into both things. We get 1 to the negative 4/3, but that's just 1, over 8 to the negative 4/3. Okay? So really, that right there is equal to 1 over, now I'm going to rewrite this 8 to the negative 4/3 nonsense in the denominator by taking the denominator of that exponent and turning it into the index of the radical. That's the cubed root of 8 raised to the power of negative 4, which turns into the cubed root of 8 to the power of positive 4 in the denominator. Okay? Because that negative exponent is in the denominator, it becomes the numerator of this fraction and a positive exponent, right? So what is the cubed root of 8? Well, the cubed root of 8 is just 2. So we take 2, raise it up to the power of 4, and thank goodness we're done. We get 2 to the 4th is just 16. Okay, so from number 38, if you look way back over here where we started, the answer to number 38 is that x is equal to 16. And that should be what you see on the answer key that's posted to Google Classroom. Okay, so lots going on there. If you need some further help with this problem, guys, we're more than welcome to look at this in class, or if you need to come by for tutoring before the test happens, I'll be around tomorrow after school as well on Friday, and Tuesday during lunch. And we can look at stuff like that. But let's finish this thing up with number 41. Number 41 is going to be much shorter, because really all we need to do is figure out what the base needs to be. This is an exponential equation where we need to rewrite both sides of the equation as the same base. Well, the first thing that I realize is that I can take 9 and raise it up to the power of 2 to get 81, right? But it turns out that 243 is not a power of 9. So is there a different number that we can use to rewrite both 81 and 243? Well, yes. After thinking about this for quite a while, you would hopefully realize that 81 is actually 3 to the power of 4, okay? And 243 is maybe you saw this already, but if we take 81 and multiply it by 3, we actually get 243, don't we? See that? So that should kind of tip you off that 81 is a power of 3 and 243 is a power of 3, because if I take 81 and multiply it by 3, I get 243 back. Okay, so 81 we're going to rewrite as 3 to the 4th, and that's raised to the 2p plus 3 power, and that's going to be equal to, turns out 243 is 3 to the 5th, right? It's one more power of 3 than 81 was, and then that's raised to the power of 2p. Okay, and so if we take now 3 to the 4th and raise it to the power of 2p plus 3, we end up with 3 to the power of 8p plus 12 is equal to 3 to the power of 10p. And now that we have the same base on both sides of the equation, I can take the exponents and set them equal, and we end up with 8p plus 12 equals 10p. Okay, so subtract 8p from both sides. I'm going to bring this right here. If we subtract 8p from both sides, we end up with 2p on one side equals 12 on the other. Divide both sides by 2, and we get p equals 6. And that, again, should be what you see for number 41 on the answer key on Google Classroom. I'm happy to go over more of these with you in class or any other time. Feel free to ask me questions, but I'm going to end the video here. So I hope you guys have an enjoyable time studying, getting ready for the test, and have a great 3-day weekend. We'll see you tomorrow in class on Friday, February 15th. Goodbye.